Okay, ladies and gentlemen, thank you once again, and great to see such a full house. If anyone would like to come in out from the doorway, there's plenty of seats here, so please make your way in and we can get started. Well, now we're going to cast our net a little bit wider into the new world of new minerals and our green energy sources coming up. And to our moderator for this is Dr. Murray Hitzman, Director of iCRAG. So thank you, Murray. I'll leave it to you.
Thank you very much. Can you hear me? Yes, there we go. So we have a lot to cover today, and we have a lot of people here to try and cover it. This is the deep dive on energy and technology, minerals and metals. And hopefully we're going to cover most of these metals, but especially we're going to cover lithium, the rare earths, and in this case, vanadium, which isn't on the list, but which is a critical mineral. So I want to just jump right in and start with Sean Sargent, who's the CEO of Green Lithium. And Sean, there's been a lot of buzz about lithium, both here at this meeting, but all around the world the last really decade now. There's a whole bunch of new projects all around the world that are being ready to come online. But there's increasing concern among buyers about the carbon footprint and the environmental impacts of many of these projects. And some of them actually are obviously having impacts on those projects going forward. As someone who really knows the lithium space, can you tell us or give us a sense of where lithium is going and how lithium companies are trying to address the imperative to reduce the carbon footprint?
Yes, Murray, and thank you very much. It's a great question. I think when you realize the importance of lithium to the energy transition and how significant it is, the role it has to play, it really is imperative that lithium is produced in a sustainable and low carbon way. Otherwise, you've eliminated all the benefit of making the transition in the first place. So I think we're seeing that. If you look at how lithium is produced in the world today, really the volumes that are produced are just a tiny fraction of what ultimately is going to be required. And if you think that roughly half and half of lithium that's produced comes either from brines or from hard rock refining, what we're seeing is a decarbonisation of both those techniques. So with brines, we're seeing increasing use of DLE technology, so lithium extraction technologies that can use things like renewable power to get to the lithium. And in our case, so Green Lithium is a company that's it's refining lithium from hard rock sources. We're particularly interested in spodumene concentrate, a lithium-bearing ore, and we're looking at how we can decarbonize that process. So fundamentally, it's an evolution of an existing traditional process. We're using a combination of things like, first of all, choosing a process that's got a lower energy requirement in the first place. That gives you an instant dividend of about 25% when you compare to traditional hard rock refining processes. But then to get the rest, you've got to focus on things like electrification of the process as much as you can. So preheating the materials and using renewable sources of electricity, of course. So you've got to have a sustainable source of electricity that you can rely on. And then where you might have used fossil fuels for the thermal part of the process, the pyrometallurgy part of the process, we're making sure that the plant we use is hydrogen ready. So our role is really to integrate a lot of different technologies so that we can produce low-carbon lithium, battery-grade lithium products. The final part of that jigsaw puzzle, so you can get about 75% reduction in carbon footprint compared to a traditional process. That last 25% comes very much from working with miners and raw material suppliers. It comes from the Scope 3 part of the emissions, and it's only really by focusing on working with partners who are also trying to reduce their carbon footprint that you can really get close to net zero carbon lithium for battery metals, but it's so important. And then, of course, the other aspect to it is producing sustainable chemicals. And for us, that means using circular economies, both in terms of being able to re-refine lithium extracted from recycled batteries, which will be so important in the future. Once you've got the material out the ground once, it would be a crime not to keep reusing it and recycling that material again and again. But also, and an important part, and often overlooked part, is making sure there's no waste from the process. So making sure we've got circular economies that can take all the material, all the byproducts that are produced by the process, and finding applications and downstream markets for those products too.
Mm-hmm. Thank you. Very lot of neat things happening there.
Sure.
Some of the things you're doing, I think our next speaker, Fortune, I'm going to probably pronounce this, Mojapalo,
That's right.
who is the co-founder and CEO of Bushveld Minerals. He also works with Bushveld Energy, which is a sister company. So again, some of these synergies Sean was talking about, working between different spaces. So you're a world leader in providing vanadium for a whole bunch of industries, right? And Bushveld Energy is working to develop vanadium-based energy storage systems. So where do you see the vanadium market moving in the next decade? And sort of exactly what Sean said, how are you trying to integrate the different pieces to be more decarbonized, more environmentally friendly?
Well, thank you, and thank you for having me here today, Murray. As you correctly say, I'm involved with vanadium, and I just need to make the point earlier on, when we're talking about the green energy transition and vanadium, vanadium is predominantly, at least today, mainly applied in the stationary energy storage. And I need to make the distinction between stationary storage and mobility, which is largely with electric vehicles.
Right.
The vanadium market predominantly in terms of demand is mainly applications in the steel sector today, where it's used as a strengthening alloy for strengthening steel. In the process, I should just add that it helps improve the carbon footprint of steel, because you add 0.2% of vanadium to a ton of steel, you double its tensile strength. That will continue to be the bedrock of demand in the short to medium term, but it is really in the application in energy storage that we see a step change in terms of the demand profile. And just to provide some context for that, we talk about the electrification of everything, right? The world consumes energy in the form of electricity increasingly. In fact, over the next 20 years, electricity's share of world energy demand is going to double to about 45%. Yeah. What's also important to note is that the vast majority of this electricity generation capacity is going to be renewable. And you cannot talk about renewable energy without talking about energy storage. And that is the reason why, even though it's still nascent, stationary energy storage is the fastest growing storage market. In fact, it's forecast to grow by as much as 122-fold in the next 20 years, from about 17 gigawatt hours just a couple of years ago to about 2,450 gigawatt hours. That's a massive exponential growth in applications. I think what's also important to note is that it is long duration energy storage that's going to be accounting for about 90% of those applications. Why is that important for vanadium? It's because that's really the sweet spot for vanadium. It's a flow battery technology. And there is growing consensus that when it comes to stationary grid-scale storage, flow batteries have a lot of compelling features. And vanadium flow batteries, what might not be as obvious to the audience, are amongst the more mature technology in that space. It's a technology that's been around for years. It's in commercial deployment today. In fact, most of the larger energy storage projects out there today are vanadium redox flow batteries. Just the other day, a 400 megawatt hour battery system was turned on in China. There is a gigawatt hour project that started construction, unsurprisingly again in China. And so the momentum is really, really there in terms of scaling up stationary energy storage, and we see vanadium playing a very, very important role within that space. The big question, of course, with vanadium is going to be the security of supply. Some focus, if you look at, for example, the World Bank Group, they focus that you will need to increase vanadium production almost threefold over the next 20 years or so, just to meet the demand for stationary energy storage. And the question naturally then is going to be, is there enough vanadium in the market, in the world for that? Well, there is lots of vanadium in the ground. I think that's not the issue at all. Whether the key question is going to be around the processing of that vanadium, and it's fairly concentrated geographically, with China, Russia, South Africa, and to a lesser extent Brazil playing a key role there. What is going to be required is the construction of processing infrastructure at a scale never seen before. And this infrastructure will either be of a co-production nature. These are steel plants that process magnetite and produce vanadium as a byproduct, or primary plants that produce mainly vanadium, and you find most of those in South Africa. Or secondary sources, and when we talk secondary sources, this is where you source vanadium from spent catalysts from the oil refinery industry. And I must just acknowledge here that I think work that the Kingdom is doing in terms of the vanadium redox flow battery value chain, there's a couple of collaborations that have been announced in the past, are very, very encouraging, because you then take what is essentially an environmentally waste product, convert that into vanadium, which can be converted into electrolyte, which powers these battery systems. I'll just conclude by just making a point around our approach to this as a company, and Bushveld Minerals being the company. And our approach was really twofold: focus on building large resource base and processing capacity at a scalable level. So today we've got 2 out of 4 operating processing facilities, primary processing facilities for vanadium in the world, and that's supplying about 4% of the world's market, but can be doubled in the next several years as the market develops. But what we also did realize is that to support the VRFBs in this sector, we're going to need to think about this in a vertically integrated way, prove the economics of VRFBs in today's market. So we are just completing the construction of an 8,000 cubic meters electrolyte facility in South Africa. We have an investment in the VRFB manufacturing, and also we've been very active in developing projects that can demonstrate today that renewable energy with VRFB solutions offers a compelling and a commercially acceptable solution. And so what we do have today actually is a supply chain, value chain that has been demonstrated and is ready for scale up. And it's not just Bushveld that's doing this. I'm pleased to see that other vanadium players in the industry are also doing the same.
The same thing. Thank you. No, that's one that I think most people coming to the session probably didn't know much about vanadium, so thanks for that. I'm going to move to Patrick Fredericks, who's a senior scientist at the Geological Survey of Finland, also a member of the Institute of Mineralogy and Economic Geology at Aachen University in Germany. And he's an expert on rare earth minerals. And the REEs are really the ones that triggered this whole debate on critical minerals almost 2 decades ago now, really. But as with lithium, we've actually found a lot of rare earths in the world in the last 2 decades. But a lot of those things aren't being mined. So very few of them have come into production. What do you see, Patrick, as the future of RE production sort of worldwide? And then being more specific, do you see a role for the Kingdom in terms of the rare earths?
Thank you very much for the introduction, Ari. First, just paint the picture of the last 20 years. So, as you know, that China has the majority in the market and still have the majority in the market in case of producing the minerals or the raw materials. There was this incident 11 years ago with China decreasing its export quota to 1/3. So, and the prices jump up to 1,500, 1,800%, especially when you think about terbium, which was at that point $5,800 per kilogram, so meaning 5.8 million a ton. So then the market and the sector just really come to a stable point, just decreasing a bit. And the last 3 years, it comes to the point that China reduces its production, according to the USGS, to 60% of the global market share at the moment. So Australia is into play, and or some Southeast Asian countries like Thailand, Vietnam, India. And you see that there is a bit of turning point in the case of that. But when it comes to when we go further in the value chain, and we comes to, for example, to the permanent magnets, which are really relevant to the time now, they still have 95% in production. So meaning everything was related to wind turbines, so green energy, green transition. permanent magnets into EV motors. So they have still the majority. And the problem at the moment what China face is the ion absorption clay deposit, which are really enriched in heavy rare earth elements, are depleting to some point. And you see the last couple of years that they're buying dysprosium, both in oxide and concentrates. So when you see that this typical permanent magnet for wind turbine, so this 10 meter average part needs at least 500 kilograms neodymium, 50 kilograms of dysprosium, 30 kilograms praseodymium, and a couple of kilograms of terbium. So you see that this mineral sector in the market will be very important in the future, and it's still important. But it's interesting how the geopolitical situation in China will be the next couple of years. And if China goes further with his strategy to be more a producer of end products or products, let's say in the second or third stage of this value chain, then you see that there is a change in the strategy. Let's see, European Union is totally dependent on this market in case of the green transition. And let me say one thing. I mean, for the MENA region, especially for the Kingdom of Saudi Arabia, it could be very important to bring this Al Ghuyara deposit, I think Abdurrahman will speak about it later, to a startup and can be a partner for the European Union or for the European, let's say, European market as a reliable partner, and that the European region can be more independent from that market. And we see a bit this diversification, but still it depends on the geostrategy of China, what will be in the future. But you see now, even Linus, for example, is just entered the US market and is playing a role in that. And it's good that they in that market and that we have a so-called small opponent of China. And yeah, that's the whole situation. And I think for the Kingdom of Saudi Arabia, it could be very essential to produce rare earth as a byproduct. So thank you.
Okay. Thank you very much. We'll come back to rare earths, I think, as well. I'd like to introduce Abdul Rahman Hussein Al-Gamadi, who's a research assistant professor of Mining and Hydrocarbon Research Institute at King Abdulaziz City for Science and Technology, KACST, as it's more usually known here. So, Professor, you're an expert in mineral and hydrocarbon exploration with a focus on geophysical techniques. So rather than speak about any one of these individual commodities, given that we need all of them, what do you see as the potential for any of these or all of these in the kingdom, and what sort of technologies are needed to actually unlock that potential?
Okay, thanks, Marie. First of all, I would like to mention to some point associated with the Arabian Shield. Geological information and the location of some mineral over the shield are relatively well known, but the buried mineral deposit relatively poor understood because of lacking geophysical and extensive geophysical and geological and geochemical studies. Saudi Geological Survey started geophysical and geochemical survey, and these surveys can help to understand mineral system over the Arabian Shield and explore new deposits in the shield. Saudi Arabia has a good amount of mineral such as REEs, lithium, cobalt, and with which this can meet the global demand. And the Arabian Shield has a good contain a good geological features, which is economically and contain economically significant mineral deposits.
Okay. Thank you very much. Let me move to our last speaker, Tony Sage, who's CEO of European Lithium, correct? And Tony just said he's had a really great day already here today.
Yep.
So I want to ask him more specifically about lithium and the kingdom or the Middle East. So how can the Middle East, and more specifically the kingdom, become a key player in the global lithium supply chain area?
Thanks, Murray. Difficult question. Look, I think humans started off burning wood. We moved to coal. We moved to oil, then gas. Now we've got solar. We've got wind. You bet your bottom dollar there's going to be technology coming up in the future. One of the ones that I read about that could blow everything out of the way is they've managed now, a London-based research firm, to get some nuclear waste and they encapsulate it into an industrial diamond. The battery will last 28,000 years. But can you imagine the average person wanting to have a nuclear-powered car, etc., etc.? So technology is increasing. There's a lot more on the horizon, obviously hydrogen. So what the kingdom, I think, can offer, other than the minerals that are in the ground here already, is to take the burden, if you like to call it a burden, for the world off China. Every new discovery of lithium, a Chinese entity will turn up and basically take the supply. So you've got a problem when, as with rare earths, 80% roughly of the world's hydroxide and carbonate for our future comes out of China. I was reading a report that one Chinese city shifted half of their bus fleet and half of their taxi fleet to electric vehicles. The pollution within the city fell 18%. If you imagine if they replicate that right across China, just in two or three of their big cities actually, there won't be any other lithium for the rest of the world. So the way I see it, the kingdom and other jurisdictions can start taking the offtakes off the main suppliers, which at the moment is Chile and Australia, and start building reprocessing plants here. They have very abundant energy resources. One of the biggest inputs into producing carbonate or hydroxide is power. So that would be a very, very good advantage to place some of these hydroxide or carbonate plants in an area where there's an abundant energy supply and a relatively cheap energy supply at that. So that's one way I think that the kingdom can offer, and that obviously would create income other than through oil and gas for the kingdom, and it also will create a lot of employment here as well. But we've really got to understand as a society that we can't rely, not for any other reason than, for example, any supply chain issues like we've got with the conflict between the Ukraine and Russia. If we have all of your supply coming from one entity, it's not good for the world.
Thank you very much. I'd like to thank all our panelists. I'd love to continue this because there's questions I'd like to ask each of them again, but we do not have time. So thank you very much, and thanks to the audience for being here.
Thank you. Thank you. What a great panel. And as we get further and further into the green metal solution, please once again thank our panelists today as they leave the stage. And we'll welcome our next panel very, very shortly. We're going for an even deeper dive now into green metals and bulk commodities. So give us a few seconds for everyone to get mic'd up, and we'll hear from the next panel shortly. Thank you.